Okay, so we left off solving this linear equation by finding the integrating factor and then multiplying both sides by the integrating factor and then rewriting it as the derivative of a product. So the next step, of course, is to go in and integrate both sides with respect to the independent variable, which is t in this case. So again, we integrate both sides with respect to t. And let's see what we get here. So in the process, of course, the inverse operations of integration and differentiation cancel out. So we just end up with our e to the 1 over 50t times x is equal to the result of the right-hand side. And then you'll notice that if I integrate exponential with a simple substitution, that the u equal 1 over 50t, I'm going to be dividing by 1 over 50, which is multiplication by 50. So that's going to make a 500 times e to the 1 over 50t plus a constant c. We can next divide by the e to the 1 over 50t. Make sure we divide both terms on the right-hand side by this. And we end up with x of t being equal to 500 plus c times e to the negative 1 over 50t. Now remember, the initial condition is x sub 0 is equal to 0. So now let's go in and solve for c. So 0 is equal to 500 plus c, because e to the 0, of course, is 1. So that's going to make c equal to negative 500. So x of t is equal to 500 minus 500 e to the negative 1 over 50t. I can then factor out a 500 from this to make it simpler, and it's 500 times 1 minus e to the negative 1 over 50t. So that is my solution, and again, its job is to tell me the number of pounds of salt at any given time t measured in minutes. So I'll now take this solution that we found and use it to answer the questions in the problem.